Thank you for joining my talk today. I will be telling you about our research on assessing the extent of land use change around important bat and habitat caves in South Africa. So let's jump right in. Caves are important habitats and, in fact, whole ecosystems that are underrepresented in conservation plans globally. This is also true for South Africa. In South Africa, we also have high rates of densification and urbanization, and this means that not only do we have more people living in urban areas, we also have urban settlements expanding across greater areas of previously natural landscapes. And this is concerning because, as the United Nations has reported, land use change and expansion of agriculture and urban areas is a prominent cause of emerging disease events, making it important to understand the effects that we as humans are having on our environment. The extent of human influence on the environment is reflected by the fact that 22% of ecosystems in South Africa are classified as threatened by the South African National Biodiversity Institute. Caves are not included in this assessment, and we don't have any cave or cave bat specific conservation actions currently, begging the question, what is happening around caves in South Africa? The reason we are interested in bats is because we have more than 60 species in South Africa alone, and at least 18% of these rely specifically on caves for roosting. Two of these obligate cave-dwelling species are reported to be numerous and widespread, the Natal long-fingered bat and the Egyptian rosette bat. But note that when we look at their distributions here on the right, they appear to be closely related to cave locations throughout southern Africa. We are interested in these two species because of their widespread nature, the fact that they have large estimated population sizes, although there is a need to do some updated and formal population estimates, and the fact that they are often found co-roosting, and this can lead to viral sharing between the two species. There are also two species that are currently being monitored because of their virological status, making this research important in terms of both the conservation of bats, but also bat and human health. So the aim of this project was to determine the extent of land cover change around known bat roosts for long-fingered and rosette bats in South Africa, specifically focusing on the extent of change in trees and anthropogenic land use categories like urban settlements and agriculture, to highlight specific roost types with the greatest change, and also to look at the current ecosystem protection levels of the ecosystems where roosts are located. Because of our limited time, I'll only be showing you some of the results. For this research, we used the cave database that I compiled during my PhD, and this dataset has 37 known long-fingered bat-specific roosts, where we were also able to classify specific roost types like maternity and hibernacular, as confirmed from scientific literature. If we couldn't confirm the roost importance, we simply labeled them as roosts. We also have 10 rosettas roosts, but at the time we weren't able to categorize these as any specific roost types, so we joined them in with the Miniopterus roost category. We could confirm 4 roosts where both species were reported to occur together, so in total we had 47 roost locations we could use in our analysis. So we first compared the roost locations to the Sunbee ecosystem threat categories to determine the protection levels of the roost sites. What we then did was create a 5-kilometer buffer zone around each roost as an average home range for South African bat species, and we then extracted the land use information within these buffer zones from maps provided by the South African Department of Environmental Affairs. And these maps are publicly available. Similar land cover categories were then concatenated to form 8 categories, and then we compared changes across these categories between 2014 and 2018 by looking at the total area of coverage, both per cave and across all caves. The majority of roosts, so 34 roosts, are not located in well-protected ecosystems, with only 13 roost sites located within well-protected ecosystems, and these include 7 roosts, 4 maternity sites, and 2 co-roost sites. From the land cover analysis, we found that across all the cave roosts, there was a 4% decrease in trees. So that's the natural woody vegetation category that you can see there on the left. While agriculture and urban areas increased. Looking at the transition matrix here on the right, we could determine that the majority of tree loss resulted from a conversion to the other vegetation category, and that indicates a shift in the vegetation from trees to more shrubby vegetation. If we focus on the distances of urban settlements to all of the different roost types, the average distance between urban areas and all of the roost types were only 4 kilometers. And you can also see that although it's not statistically significant, there is a trend of decreasing distances between urban settlements and roosts across all of the roost types. And I would like to illustrate this change by using the example of the Grootboom Cave, which is one of the caves that we visit monthly to sample bats, and it is located within an urban area. This first image is from Google Maps and it's dated 2005. And in this image, you can see this area, which is called the Irene area. And you can see the location of the cave here indicated by this red pin. And in the surrounding area, you can see some buildings, but overall, there are not many buildings and there's not much happening around this area. And you can see that there is also still a lot of natural vegetation. If we fast forward to 2014, the change is quite notable, with approximately 2 square kilometers of luxury housing springing up across the road from the cave. And if we look at this same area now in 2021, we can see that the whole area across the road has been developed, with houses stretching right to the road and being only a few meters away from the cave. And the access to this cave is uncontrolled, so anyone can visit the cave. And we have observed an increase in litter around the cave, as well as evidence of fires around and inside the cave. There is evidence that someone does occasionally live in the cave. So this cave really does have a lot of human visitation. And there is a population of Natal long-fingered bats living in this cave. So I think the take-home message is that land cover around bat-inhabited caves in South Africa has changed and will continue to change. The loss of trees and increasing urban expansion probably means that encounters between bats and humans will likely increase. And while we do not yet have any direct evidence of what this means, we can speculate about what this means in terms of both human and bat health. Remember right in the beginning of the talk, I mentioned that the United Nations stated that land use change is a major contributor to emerging disease events because humans are encountering wildlife that they normally wouldn't have contact with. Bats are adaptable animals and they can and do adapt to human-altered environments to an extent. But even if they do adapt to urban areas and agricultural areas, they'll be exposed to more pesticides and pollutants, and this can lead to things like behavioral changes, immunosuppression, and increased pathogenic infection, which could mean that bats are more likely to get sick from viruses that they carry, or that they might shed more virus. Secondly, because caves are not formally protected, we'll see an increase in roost disturbance and vandalism, as we ourselves have observed at caves like the Grootboom Cave, and as also highlighted by this paper by Ferreira et al. And this publication also shows that being located in a protected area does not guarantee effective conservation, because the researchers observed a high amount of graffiti inside the cave, as well as a lot of dead Rosetta's bats throughout the cave, and they couldn't establish the reason of death for these bats. So I think this research highlights the fact that we need to determine the extent of human influence on important bat-inhabited caves, particularly the maternity and co-roost sites, which would mean physically visiting these caves and doing assessments. Most importantly, I think that while conserving the surrounding areas is also important, we do need some cave-specific conservation actions to protect these important habitats not only for bats, but also for humans in the long run. Thank you for listening to my talk. Please feel free to contact us via email with your comments, questions, and ideas. I'm also online and available for questions.